Hello, star people. Welcome back to EarthSky. I'm Deborah Byrd. On the subject of our local star, the sun, I want to show you something going on now that's subtle, beautiful, and very much a matter of perspective. What you see here is a total solar eclipse with the moon's shadow falling on the Earth, but that's not what I'm talking about today. Here's what I'm talking about. That red ball is the sun again, and you're watching another eclipse, but it's not an eclipse by the moon. It's an eclipse of the sun by the Earth. This is the view from a NASA spacecraft, the Sun Observing Solar Dynamics Observatory, or SDO. And I'm speaking to you on January 28th, 2026, right in the middle of SDO's twice yearly eclipse season. This is eclipse season 32 for this spacecraft, which has been orbiting Earth for 16 years. This season started on January 6th, 2026, and it'll run through February 1st. During this time, Earth will block SDO's view of the sun for up to 72 minutes each day. Eclipse seasons for this spacecraft happen because of its special orbit. And a quick reminder, the Solar Dynamics Observatory launched in the year 2010. It was headed for an orbit approximately 22,000 miles, about 35,800 kilometers above Earth's surface. It was a beautiful launch. And its final orbit was far enough away from Earth that it can observe the sun almost continuously without having to worry about Earth's day-night cycle. In other words, for most of its orbit, SDO can look over the sun, or not the sun, over the Earth or under the Earth to see the sun. But meanwhile, the darkest part of Earth's shadow stretches approximately 870,000 miles or 1.4 million kilometers into space. That's nearly 4 times the distance between the Earth and Moon. So Earth's shadow is long, and the spacecraft's orbit is inclined to Earth's equator by 28.5 degrees. And that means the geometry of the sun, Earth, and spacecraft aligns perfectly twice a year to give us the 3-week-long eclipse seasons like the one happening now. And during these weeks, Earth's shadow falls on the spacecraft for at least a few minutes each day. And as we do on Earth, when the moon's shadow falls on our world, SDO cameras see eclipses. And again, the longest of these eclipses lasts about 72 minutes. And so this is a spacecraft that's designed for continuous observations of the sun, but the eclipses by Earth create short gaps in the SDO data, and space weather forecasters have to factor those gaps into their daily monitoring when the eclipse seasons are happening. EarthSky is lucky to have a heliophysicist or sun scientist working with us every day. He leads the daily sun news update at earthsky.org. He couldn't be here today. He's at a meeting in Houston, but some of you know him, or at least know his name. It's Dr. C. Alex Young, based at Goddard Space Flight Center in Greenbelt, Maryland. And scientists at Goddard also operate the Solar Dynamics Observatory. Alex told me this week that the scientists and engineer who operate SDO don't just shrug and power through the eclipse season gaps in the data. They use these eclipses to help monitor the spacecraft's instruments. For example, they monitor temperatures, and they also use the time to send needed commands to the spacecraft, for example, to help maintain its batteries. So these Earth eclipses by SDO are expected, modeled, and planned for years in advance. And just a few words about SDO itself. It truly is an amazing spacecraft. And stay with us because I've got a highlights reel from SDO coming up. But first, it's this spacecraft's job to watch the sun at multiple wavelengths. And that's why in the SDO images, you see the sun in different colors. The different wavelengths let scientists track sunspots and solar flares and huge eruptions on the sun called coronal mass ejections, or CMEs. These huge blasts routinely send clumps of solar materials and magnetic fields out into the solar system. And there's been a lot of talk here on Earth about the potential of these sun blasts to affect earthly satellites, power grids, and communications networks. And that's why it's so important for the Solar Dynamics Observatory and other sun-observing spacecraft to keep their robot eyes focused on the sun. And one more cool thing to notice, SDO images also sometimes show another dark shape sliding across the sun, and that's Earth's moon. SDO doesn't see moon eclipses as frequently or as regularly as it sees Earth eclipses, but moon eclipses, as seen from this spacecraft, do happen a few times every year. And see how the edge of the moon looks sharp here? So you can easily tell that the SDO moon eclipses are not the SDO Earth eclipses, because during an Earth eclipse, the edge of the Earth looks blurry. And that's because, unlike the moon, Earth has an atmosphere. So if you ever see images like these of a fuzzy-edged black arc intruding on the sun, you'll know that's the Earth. And what you're seeing here is a sped-up image. In fact, the real curve in real time moves slowly during an eclipse. By the way, I love using the word eclipse here because it reminds us of how much that word depends on where we're standing. And to me, that's what's so beautiful and profound about these eclipses of the sun by the Earth. We tend to think of eclipses as dramatic, rare events, totality, and crowds. Yes, it's an amazing universe. Special glasses to view the eclipses. But this SDO eclipse season that's going on right now, with an eclipse every day, isn't something we notice from Earth at all. It only exists for us because we've learned to see somewhere else from somewhere else in space. And from the perspective of the Solar Dynamics Observatory, Earth itself and all of us who ride on Earth become the eclipsing body. So it's a wonderful example of how in astronomy, a change in your vantage point often means the universe rearranges how it appears to you. So I'm open for question. It is cool, Sally. Thank you. I'm open for questions. If you have any, please write them into the comments box. And as promised, here are some highlights from the great sun-observing spacecraft, the Solar Dynamics Observatory, or SDO. As of January 2026, it's been orbiting Earth for 16 years. And as you watch, you'll be seeing the sun in a range of wavelengths, and you'll be seeing sunspots, solar flares, including some X flares, and those big CMEs, or eruptions from the sun that I talked about. And there's also a few sun-grazing comets in here. Those are comets that sweep in close to the sun. And I want to invite you again to EarthSky's daily sun update. We update every morning before 7 a.m. Central. That's a new post by 13 UTC Daily. There's a comet right now going past the sun. Whoosh. And in the Sun News Update, we talk about the previous day's flares and the solar wind, and we alert you to any possible upcoming geomagnetic storms and auroral displays. And I also put the link to EarthSky's daily sun update in the post notes. So what have we got? Any comments? Any more comments, you guys? Okay, Jeremiah, let's look at those eclipses one more time. And so remember, if you ever see something that looks like this, like the sun is being gently erased, now you'll know what you're seeing. You're watching the Earth pass in front of the sun, temporarily blocking a spacecraft's view. It's an eclipse that only happens because in astronomy, your vantage point matters. Thanks for watching today. Sally's mesmerized. I know, Sally, I was mesmerized putting this, this stream together. It's beautiful. Uh, thank you all for watching, and thank you to Jeremiah Guajardo, our producer, and to Marcy Curran, who is monitoring our comments. As always, keep looking up. One Earth, one sky, EarthSky.